Hey guys, this is Matt, that's me here. I'm working on the Esri R&D Center Zurich, where CityEngine is being developed, and I'm usually the guy who answers all the questions on the CityEngine forum. So that's me here. Now I've seen one of the threads which has been going on for quite a long time now, which was started by Nicole Hansen here, and I decided that I wanted to make a quick video on this one and explaining a little bit more about what I have told her, how CityEngine actually is used to create proper streets. Now I posted here on the post 13, I posted a little rule file here which was called, or is called, streetrule.zip. That's a CGA file, and I've taken this actually and added some more features to it, and now I wanted to have a look at it in detail and explain to you guys how this stuff actually works. I've seen there are some misunderstandings how CityEngine actually works, and I want to go in and answer by far most of the questions concerning how CityEngine creates street models based on street shapes in CGA. So let's go to CityEngine. I have an open scene here, and let's have a very quick look at the rules. So we're going to step through all of that code here in a minute, but let me start first here in the viewport. So I'm going to maximize it with the space bar. Okay, so you see down here there's the so-called navigation display. You can activate this by going to this little cogwheel render settings menu and then go to the navigation display. If you don't see it, you can also just quickly go in and press the keys DN. So I'm going in, DN, oh that was DG, sorry, DN, 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 and so on and so on. Now you see that the current grid, if I'm just moving the mouse a little bit here, you see the grid size is currently 100 meters or 100 units. So if I'm zooming in or zooming out, the grid dynamically adapts. So I'm going in to about 100. Now I'm going to press the G key to actually create a, by the way, that's the same here as the polygonal street creation tool here. And I'm going to create a street which is about 300 meters long. So I'm going to start there and then there. Okay, enter. Now the next thing I'm going to do is I'm going to activate this guy here, edit street curves, edit streets tool basically. I can do the same thing with just selecting the shape and then hit the C key, press the C key. Okay, now I'm going to edit the tangents of that street, so you see that it's going to be a little bit curved. Okay, so that's about it. By the way, if you're looking a little bit from top down, then you can edit the horizontal components of the tangent. Now if you look from this glancing angle, you can actually edit the vertical component. Gonna undo this. And sometimes if you get this line here, just grab one of these points and move it around a little bit. That's a refresh issue which should be handled in one of the next releases. So what have we here? So let me open the inspector here and let's minimize this. Let's just move this over here. So what do we see here? We have visible one street graph, we have a couple of shapes, and let's for now look just at the shapes. So if you select all of that stuff, we now see in the viewport up here that 3 elements are selected. So one of these guys is a sidewalk. Then the middle one is a street, and the third guy again is a sidewalk. So we see that CityEngine has by using these dynamic city layouts tools, has created based on one curve, one street and its two sidewalk shapes. Now if I'm selecting this center line here, basically the graph, then actually just the guy itself, so it's blue. Now you see there are some settings. So the default width is 14 meters and I can go in and edit that interactively. Now I'm going to select the right shape here, and I think this is not wide enough, so I'm going to select again the graph and edit the right side. And yeah, let's make the other one a little bit bigger too. Okay. So now what we have actually produced is 3 shapes. That's how CityEngine creates shapes. Now the next step which we are going to take is actually see how this CGA code can take these shapes which we have just produced and actually create a 3D model out of it with all the textures or colorizing and extruding and so on and so on. So the code which we see here, which we are going to use to split some lanes and a medium in here or not, but that's up to the attributes which I'm defining here. So I'll talk about this in a minute. Okay, so let me hide the street graph and go in here, select these shapes, go in and select the rule which I'm going to assign. So that's the, where are we? Too much stuff. New street rule, and I'm going to hit open. Okay, now we see I have already created a lot of stuff here which looks a little bit complicated, but let's go through some of the code of the very first basic code first. So let me open here and see what we have up here. So we see that inside the rule file which we have assigned here, there are some rules which are defined. So one is crossing, that's the case. Actually, let me create one. So if I'm continuing right here, now you see that this shape here is actually called or has the start rule. No, it doesn't have it currently. Here we go. We have a crossing. So depending on what the shape actually symbolizes in reality, we have different start rules. Now, since we can define those start rules in different rules, that's up to the user. I just decided that I want to have all of these elements in the same rule file, and that's actually the reason why I have the crossing also defined in here. Now you see here crossing, it starts, or it would start with that geometry here, pass it on to the next rule, but this is not defined, it just stops here. So the point here is used to just stop the execution of CGA at this point and create a model based on this. So I'm going to use here, for example, color 100, so that's in color in RGB, so red, green and blue. In this case red is 1, so this will become red. So I'm making sure that I'm showing actually my models, and I'm going to in and hit the generate button. So this is taking a second, and there we go. Okay. By the way, with the 7 key here on the keyboard, I can toggle the wireframe. That's the same as in the render menus, here in the render setting menus, and clicking here, wireframe unshaded or textured. So for now I'm going to hide with DG, I'm going to hide the grid DG. Okay, now we see that if I hide all the shapes and all the street center lines, I now have a red 3D model. So I see that this is a model. So this is the final result, which was created based on the input shape plus the rule. And that's the main paradigm that CityEngine uses. Always you go from a shape, you assign a rule, you define where in the rule to actually start. So at the moment the start rule is crossing, so CityEngine knows to start here. Then it makes it red and writes the shape called crossing, or the model called crossing. Okay. Now the two other shapes which we have here, which are the sidewalks, I'm just using nil in capital letters, so that just deletes the geometry which comes from the shapes. And let me generate those with Ctrl G, that's the shortcut for this button here. And you see if I hide the shapes, there's no geometry created. So nil actually deletes the geometry. So all the crossings and all the sidewalks, I'm not going to dive into those anymore. I'm just going to assume that you may continue with the stuff you have learned in this lesson and create something similar to what to the sidewalks, something similar as we are going to do to the streets. You could add trees, you could add people to those sidewalks, you can add bus stations, and so on and so on. So that's really powerful in CityEngine what you can do basically. So I'm going to delete all of these models there. So again, let's go and focus on the street, on this street shape. So let's go quickly down here. And here is the definition of the street rule, and here we actually start. So I'm going to quickly comment out this stuff here. You see that's a multi-line comment out. Here I could also go in and just hit or just put in some of these pound signs here. That's the same for individual lines. Now you see there's an error because I'm not closing or just basically finishing off that rule here. Okay, so let's also try here colorizing that shape and generate the model with Ctrl G again. So you see also this guy obeys and creates a simple red model. Now you will see down here we have these very weird expressions which are called in this case geometry.du 0 unit space. Now what this does is it actually calculates the width of this street shape which was generated just before, and if you have actually du is the length, sorry, du is the width. Now as you see here, this 0 that is calculating the unit space in texture coordinates in the first UV channel basically. So that's what this does, is it calculates the width based on the texture coordinates. Now this is a little bit complicated. I'm going to talk about this in a little bit more detail just later on. But what we are going to build on basically is that we can use texture coordinates on shapes to derive the split directions. And for all of the street shapes which CityEngine produces, the so-called UV textures or texture coordinates have already been created correctly. So if I'm going in and for example use the polygonal shape creation tool, like this shape here does not have proper UVs. So let's quickly show a texture on this street and visualize what these or what this actually looks like. So I'm going to use texture built-in uv test.png. Save and generate again. Now you see this looks a little bit weird, but we have a built-in texture which goes from here and stretches all around the shape, the street shape. Now if I'm doing the same thing on this shape here, so I'm just quickly going in and selecting the same rule, new street rule. I don't have a start rule, an empty start rule defined here, so I'm going to skip this and I'm going to define this as just shape and just quickly add the start rule in here and just copy the texture to here, save. Now I'm going to generate this here and you see it's all white. Now this is because the UV coordinates, as we have talked about them here, are not properly defined. So I could go in, of course, and say setup and then control spacebar to open the command completion. Use the first one, 0, that's the first UV UV channel basically, then scope dot x and z, relative 1, relative 1. I'm not going into all the details here. Then project UV in the same channel here. And now you should see that the texture is actually, let me make that relative negative 1, otherwise it gets mirrored. And now you see that here we also have the texture shown. So I'm going to select this point here, move it a little bit around, and you see that the texture is projected accordingly. Okay, so let me delete this shape again and delete that stuff here. Now, since we are using this trick of splitting along the UV coordinates, that gives us the possibility to use these and split lanes from this very wide street shape and create, for example, traffic which on the right hand side goes in this direction, on the other hand goes in the other direction, and so on and so on. So that's the system we are going to build. Okay, now I'm going here quickly to show you that I can also tile UV, and I can also edit these UVs again. Texture which I'm going to say approximately 2, and this should then, when I regenerate the model, that's a little bit tiny, but we have a very, very wide street. So you see that now we have tiled all of these texture repetitions and they obey the whole geometry. Okay. So let's also go in and take that stuff out again. Save. So that's the starting point. Now, where do we start? Okay, let's start at the very top here with the attributes which I have defined. So you see there's, for example, the attribute called driving sense, which has a default of right. So that's the default, for example, in I would say most of Europe and in America, where people just drive on the right lane. And in the UK, for example, and in other places in the world, people drive on the left lane. So we want to have an attribute which actually defines whether you drive right or left. Then you see there's this annotation, which is the @group annotation. So what this does is, if I'm opening the inspector a little bit more here, you see that drives basically the layout of the inspector here. So if I'm having @group lanes at the position 0. You see there's another group details at the first or at the second position, so it starts at 0 here. You see that the 0, the first actually, is placed first and the second is placed second. Then within each of those groups you can have other a sub-layout basically, which is driven by the order. So 0 is the most important attribute, 5 in this case is the least important position or attribute within that group, and so on and so on. Then there's another annotation called range, which defines the defaults which are selectable when I click here on the triangle in the inspector. Left, right, and so on. Now, if I want to go back to the defaults, you see here I have a user set value which is written in bold. I can just click on the right mouse click, reset all attributes, or just reset a single one, up to you. Okay. So we have an attribute which defines whether the whole street, there's already something created here. So the question is whether the whole street should be one way or whether it should be subdivided with a median. So there's another attribute, whether we should do a median or not. And then there's the lane offset. I'm going to talk about this a little bit later. Then we have the lane width. So this would be the default width of one lane. In this case, we have one lane is about 3.5 meters wide. So we are going to use this as the first input. And then we define as the last attribute in this group here, we define the median width. And the default is here just 0.6. So that's about 60, or that's 60 centimeters. One annotation I forgot to talk about here, so whether there's one way, you can define this even better. So if there's no one way, there's going to be two driving senses or two lanes going in opposite directions. Then there's one way in one direction and one way in the other direction. So that depends on whether you have let's create, for example, a street from here, from the starting point to the end point. So if you set the attribute to one way, undo, then the traffic is supposed to run in this direction as you have drawn the street segment, basically. If you do it to the one way reversed, then it's just going the opposite direction. Or at least that's the behavior I defined that way. Okay, then next group here, that's going further than further than what we have seen already in the thread so far. So there I'm already trying to add some pedestrian crossings, and there's the question whether there are none. For example, we don't want to have any pedestrian crossings on a highway, so there you would set none. Or on small streets you may want to have them all for example 100 meters or so, or just at the start one and one at the end. Okay, so that's it about the attribute definition. Now, as you see here, one of the questions which was posed later on in the thread here is, why is there no attribute which defines the number of left lanes and the number of right lanes? Now, why cannot I define an attribute which does it this way? The reason for this is that you define the total width of the street already on the graph segment. So currently you have defined 34 meters, so that's quite wide. But this is the very first step before even, or this is the shape creation step. The second step is to take that shape and use CGA to create a model from this. So the width of the total street with all the left lanes and all the right lanes is already defined in that shape here, or in that street width here. So what we are going to do is we are going to write the rules as generically as possible and write the code so that it doesn't matter basically how wide the street is, but CGA actually produces the correct number of lanes, right lanes and left lanes, based on the total width which you have defined before to actually create the shape. Okay, maybe rewind the video if this went a little bit too fast. So we're covering a lot of stuff at the moment, and the video is already 25 minutes long, so yeah. Okay, let's go in and talk a little bit about the functions, because this is the very first which we are setting here. So actually no, let's start here with the street start rule. So here we see that we start at the geometry of the street. So the first thing which we see is here we are doing 3 sets, and set always lets you set an attribute value. Now you see here actual lane width, number of lanes left and number of lanes right. These are 3 hidden attributes. So if it's hidden, that's, by the way, that's another annotation type, it does not appear in the inspector. So if I'm selecting the shape again, then you see there's all the attributes which we have defined at on top, but there's no n lanes left on the visible here in the inspector. So that's okay. Now what we are doing here is the actual lane width. We are going to initialize this at the very beginning with a start value of 0, and then we are going to set its actual value, or its actual dimension, based on a function. So the actual lane width function, that's the function which we have defined here. Now there's a quick note here. Functions are calculated on the current shape. So since we are starting at the very beginning, the input shape is the street shape. So this calculation is done based on the street shape's total dimension. Okay, now what does this function do? You see here there's this equal sign which basically evaluates the CGA code here and then returns the value which was defined here to set the actual attribute. So this function here returns returns a specific value. In this case it's going to be a dimension in meters, so a float value, or just a number basically, and set it to the actual lane width, and instead of the default value, which is 0. So let's go in and look at the logic which is encoded here. So we have a case statement. That's basically if or else. So if something is true, I could also write, that's the short form here, case do median, and then the semi, no, that's, what's that sign called? Double point, colon, I guess. I could also write equal true. So that's a test whether do median, this attribute here, is true, or in the else case it's not true. Now remember, do median, that's an attribute which we have defined up here, and the default of this Boolean value is true. It could also be false, but that's up to you, or up to the user which uses the rule. So if this guy is true, let's go back to the short form, then calculate this. Okay, now let's make this a little bit bigger again here, so we see the actual shape of the street. Yeah, Okay, so what's the intelligence here? So in case we want to do a median, we are going to take the width of the street, so the dimension here. We are going to take away the median width, that's the 60 centimeters, and then we are going to divide the value which comes out, basically the rest which is left on which you can create lanes, and define or divide this by the lane width which we have defined also as an attribute. And this will be not an integer, basically. This will be a value of like 5 lanes and 0.324. But we want to have full lanes. So what we are going to do here is we are going to round to a full integer. So rint rounds the value up or down to the next full number. So 5.44, that will give, that will be 5, and 5.9, that will go to 6. That's just basically rounding. That's very simple. Okay, now in case we do not want to have a median, we don't need to take away the median width distance, but otherwise the function is exactly the same. So let's say we our street were let's make it a little bit less wide. Let's go to 18 meters, and let's define, or if we would define the lane width as 3, this together would result in total 6 lanes if we are not doing a median. Okay, so let's go back here and save again. I hope so far everything is understood and correct. So let's go back here. We are setting the actual lane width to this value of the function. Now you may ask, we have already defined the lane width as 3.5 meters. Now why would I have to redefine it? Now the reason for this is because we are splitting the geometry into a certain number of lanes, but each individual resulting lanes may not be exactly 3.5 meters wide. It would be, of course, if we would have 3.5 meters set, or if the total width of the street, this guy here, the street width, would be a multiple of the actual lane width, then this would be correct. But if it's off by, for example, 50 centimeters, and that will result in a couple of centimeters off. Okay, so then the next function which we are calling is number lanes left, the number of lanes left function, and we are going to set this to the other hidden attribute, and we're going to do the same with the number of lanes right. So let's have a look at this code there. The number of lanes left function, what does this do is it calculates something before. So the number lanes total function, that's this guy here. So it goes in, takes the value of this function, divides it by 2, because you may, or if you are doing a median, or if you have opposite driving senses, so a couple of lanes going in one direction and a couple of lanes going in the other direction, usually the median is in the middle. So we are taking the whole dimension of the full street divided by 2, and then here we add the lane offset, and we round the whole thing first. Here, that's a little bit difficult to understand here. So first we are taking a number which is approximately in the middle of all the lanes, to define where the medium is. We define it as a full number, and then we add the lane offset. Now what this actually does is, if I'm generating the model here and quickly hide the rest, we see here, since 5 lanes are resulting, we don't want the medium to be in the middle of the middle lane. So this is the reason why we have to round to the from the middle to the better side. So for example, to the left side or to the right side, but it's always at the end or at the side of a lane. It's never in the middle of a lane. And the offset, that's where I can define, for example, if it's -1, I'm going 1 lane over. If I'm defining the lane offset is 2, I am going 2 over to the right side than what the default is. So that's just a way, this lane offset here, this is a way for me to drive where the actual median is going to be. Okay, so I'm going to reset all this stuff here. So back to the code. So that's the number of left lanes, and the number of right lanes is actually the number of total lanes, which we have here, and then minus the number of left lanes, which we have just calculated. Yeah, so that's the number of left lanes total function. Then we have the actual lane width function here. So I may have messed this up a little bit before. Okay, so then the actual lane width function, again, the topic here, whether we are doing a median or not, which takes away the median width and calculates by the number of or divides by the number of total lanes, and then uses this value as the actual lane width. Yeah, so far so good. There's another function I'm going to talk about in a few seconds. So what we have done at this very first point here is maybe the most complex element, or the most complicated step at the very beginning of the rule, because we want to have access to some of these attributes later on, so we are going to define these values here. Okay, then it continues to the next function, or to the next rule here. The rule is called split pedestrian crossings. We have some functions here, which is called pedestrian crossing width, which is 5 meters, and pedestrian crossing distance, which is 100 meters. Then we continue. We have the actual rule definition here. So we jump from here to here. And what's going on here? So we have this attribute here, which is tested. So again, let's go up to see the definition. So this could be pedestrian crossings. This could be either none, or start and end, or repetitively. So the first test is if pedestrian crossings is actually none, don't do anything and just continue directly to the next rule, which splits the geometry of the streets. Case pedestrian crossings is start and end, then we want to have, so this is repetitively. I'm going to quickly set this to make that a little bit wider. So no does not make any yellow pedestrian crossings. If I set this to start and end, I just have one at the very beginning and back there one at the end. And if I'm actually using repetitively, you see every 100 meters one of these guys is created. So let's go back to the code and see how that is coded. Okay, so the next case is case pedestrian crossings is equal to start and end. Then we add another test, whether the full length of the street is bigger than 50 meters. Then we do a split in the u direction, basically in the length direction. So this is the length direction, so we are splitting this tiny part of 5 units to actually get a pedestrian crossing shape, which we then colorize yellow afterwards. And we do the same thing. So we see here the dimension pedestrian crossing width gives pedestrian crossing, that's the shape. Then we say the same thing at the end, once in the beginning, once in the end, once here and once in the end. And in the middle, the big part in this case, where there are going to be no other pedestrian crossings, that's going to be approximately 1. This is floating value with the tilde sign, so this adapts to any dimension. And there we are going to continue to the next rule, which is split street. So go and split the rest of the street into lanes. We're coming to that in a minute. Then the second case in this case here, or the second sub case in this case, where we are just creating a pedestrian crossing at the start and at the end, is if the street is actually wide or longer than the pedestrian crossing width. So here you see there's the case where it's very long. In the case where it's just a little bit longer than the actual pedestrian crossing width, then cut it just at the beginning, so for example here, and then make the rest just a street. And if the actual street length is shorter than the pedestrian crossing width here, so for example there would not even the street is so short that you cannot even build one full pedestrian crossing, then do nothing and go directly to the split street rule, to the next rule. So that's the default case here, where nothing happens basically. And then we have the last type of pedestrian crossings splits, which is the repetitive one. And here you see again split in the u direction, that's along the street in unit space. That's actually cutting in meters here, and the u we set 0. So here we are using unit space because we are using meters as inputs. And here you see bracket open, curly bracket open twice, then pedestrian crossing width, then approximately pedestrian crossing distance gives street split. Close the first, or close one of the brackets again, set this to a repetitive pattern, and then cut again at the very end into a last pedestrian crossing without another repetition. So here you see it's a little bit complicated to see at the very beginning, but the structure is basically something like this. So there's A, B, and A. So A is the rhythm, basically the split rhythm, which we define here is first we have the pedestrian crossing, which we split, then we have the distance. This gets repeated as many times as possible, but evened out so that at the very last position we still get a pedestrian crossing back here. Okay, and that results in the geometry you see here. So you see we have one pedestrian crossing at the very start, one at the end, and in between the other guys are actually evened out. So that's cool. Then if none of the pedestrian crossing values or the strings here are defined, just delete the geometry to give the user basically a visual indication that he messed up an attribute or something in the attribute or in the inspector. Okay, so we have defined the positions of these pedestrian crossings, but now let's go in and split the actual geometries of the streets between the pedestrian settings, and let's split them into a median and into lanes. So what's happening here? So there's another case statement which I have defined. So there's the case one way equals one way, or case one way equals one way reversed. So if I'm going up here, we see again there's the attribute which is either no or one way reversed. So I've mentioned this before, so let's quickly go in and set these guys. So let me reset all and go here to one way. Now you see the driving sense here is defined as right. So the right lane is colored green, so these guys always drive in that direction. So if I'm going to change to one way reversed, all of the lanes are red. So red means in this case they are driving from up there towards the street starting point. If I'm changing the driving sense, for example, to something like Tokyo or London, then the whole system would get reversed. I'm going to talk about this in a second again. So we have seen when we are defining a one-way, that's basically the easiest way to create streets on that street shape, because we will not have to deal with the median, because on one-way streets there usually are no medians, and we don't have to deal with the differences between whether or which side drives in which direction. So we can directly forward this to lanes, which will split into individual lanes, and then here we are defining the actual driving sense or driving direction. So here we are, since we have defined that the default for us here is to drive on a one-way or to basically live in a city where the standard driving sense is right, then I'm passing on this value to the function, which I mentioned before that I'm quickly going to talk about. So that's the last function we have here, the driving sense function. The input is a sense, so in this case here the input is right. So for example, I'm in New York or here in Zurich where we are. So if the driving sense is actually no, I'm confused. So if the driving sense, the default driving sense is left, then return the same sense. That's actually messed up, but yeah, let's not deal with this at the moment, but it should be okay. So now if the sense which comes in, or again, so if the driving sense, if the default driving sense is left, then return the sense. By the way, again, driving sense is an attribute, so the default is right. Now if the driving sense or if the incoming sense is left, then inverse it to right. If right is inverse is coming in, then give back left. So that's a little bit complicated what actually happens here. Okay, where are we? Here. So we see that we are passing to the next rule all the one-ways in this case and in this case. And then comes basically the standard definition whether we are doing a median or not. So this is a Boolean attribute which you can define as on or as off, or true or false as just defined there. And here is actually the very heart of how to create these different geometries of the streets. So what we see here is we have a split in the V direction, in the V texture coordinate direction. And we have this split here. It's dividing into three parts. The left part, then the median part in the middle, and the right part. So that means if I'm going to just quickly deactivate the lanes rule with a point, and I'm regenerating the geometry, then now you see that we are splitting a left side, we are splitting into the median, and we are splitting into the right side. But there are no actual lanes created. It's just about left, middle, right. If there is no median created, we have just left and right. So that's the same in the code, or in the next line here. So if we don't create a median, just split into confusing again. Yeah, anyway, just got too complex. I lost it. Yes, okay, so let's... Actually, that should be a little bit different. So we should have a right side and a left side. So I'm missing this here because as I just discussed, we should have a left side and no medium and a right side. So I'm actually missing here in the code the left side, but I may fix this in the code, which I'm going to post again on the rule on the forum. So let's just simply continue. Now I deactivated the next step or the next rule, which is the lanes. So what you see here is we split again in the width of the street into the lane width, which we have defined at the very start here. So we are defining, that's actually also using the wrong value. I'm wanting to split in the actual lane width, not in the lane width, like so. And this splits into single lanes. So we are coming from lanes with decidedness, whether we are on the left side or on the right side. And then we are splitting into the actual lanes with a repetitive split, which splits into actual lane width pieces, basically. And then the very last step, which we have here, is the actual lane. Now that's the single, or that's the resulting geometry. Here we define whether the side of the lane is a right lane side. We colorize it red. So red is has a higher value than green and blue. And whether it's a left lane, it's going to be 0.5, 0.6 in green. So that's going to be a little bit green. And again, 0.5 in the blue channel. Last thing here, the median is just getting extruded with 1 meter height and colorized to a darkish gray. And down here, the pedestrian crossing, we are colorizing this in yellow. So 110, that's yellow. Okay, so as we see here now, the result of what happens during the CGA code is geometry which obeys to whatever input I give. So I can drive, or I can say the driving sense, the default is actually left. So let's quickly go back and fix this in the code, which I mentioned before, which got me a little bit confused. The default is left. Is that correct for me? No. Right is the default. That's okay. Default is right. Right is right. Yeah, that's actually correct now. Okay, so right, what is red is my main driving direction. So let's make that a little wider and play a little bit with the code which we have created. So I can change to left, and you see only the color changes. Then we can say it's a one-way, just in the left sense, or just in the right sense, depending on going from the start to the end of the street or the other way around. Quickly going back to the default, I'm going in, zooming in a little bit, and turning on and off the median. Do median yes or no. You see that there's a little bit of shrinking going on the actual lane widths. So that's the reason why we need to have that distinction in the actual lane width function, whether there is or not going to be a median. And again, we have played with this before, the offset of the lanes, the lane widths, make them wider, make them narrower, go back to the default and play with the median width here. And last but least, just play with the pedestrian crossings. Okay. None at all. Start and end repetitively. Okay, so I think that's it for the video. It's been almost an hour that I have been talking now, and I will quickly go in and check the code and post this new rule file. I'm going to check also the issue which I had with the split here, where I thought I'm missing something. So the next rule which I'm going to place on the forum thread will have this fixed, and I hope I'm not gonna have too much trouble uploading this big video to the forum, or otherwise I'm gonna place it on another source and or another resource page or so, and link to this forum thread. I hope you learned something in this video, and yeah, until the next time, take care.